For this podcast, please have note page number 17 in front of you. The fourth functional group within our series is going to be the aldehyde. And with the aldehyde functional group, what you're going to have is a carbon double bonded to an oxygen completed with a hydrogen off the end. All right, so this is what you're actually going to be looking for right here. All right, and you can see with the R, like we noted before, that's the rest of the organic compound. Now, the example that's given to us, propanol, right? And here is the location of our aldehyde to give us the name propanol. All right, let's go to page 17, continue on with aldehydes. All right, now with aldehydes, what you have is a carbonyl group. That's the dash carbon attached to a double bond of oxygen. What is not shown here is that the other bond associated with the carbon is going to be a hydrogen bond like such. Okay? Now, typically, these aldehydes, the carbonyl group, is going to be found at the end of a hydrocarbon chain. Nowhere in the center, always found at the end. The E at the end of the alkanes is going to be replaced with an Al. That signifies an aldehyde. Now, the key is this. Be very, very careful with the aldehydes. They are very similar to the ketones, which we'll talk about in a future podcast. All right, examples. First example, we have propanol. All right, the prop portion tells us that we are dealing with 3 carbons. One of those carbons is going to be part of the carbonyl group. All right, there's our 3 carbons, and to prove that we are dealing with an aldehyde, we have to represent our double bond of oxygen, and here's our hydrogen attached in the 4th location of the carbon atom. And of course, these are all going to be hydrogen bonded as well. So propanol, 3 carbons, with the aldehyde group, the carbonyl group, located at one of the 2 ends. Now, the next example, we have 1, 2, 3, 4, and yes, we're going to count this carbon as well, even though it's part of the carbonyl group. We have 5 carbons. 5, the prefix we use is pent. Go that far because we would call this pentane if it wasn't for the carbonyl group or the aldehyde at the end. So pentane is where we're going to start. Now, because we're dealing with an aldehyde, and here's the location of the aldehyde right here at the very end of this organic chain, we're going to put an Al at the end. Pentanol, right, representing the 5 different carbons. You never ever want to put a 1 or 5 based on the location of where the carbonyl group is, because we know when dealing with aldehydes, the carbonyl group is always going to be at the end. So it's not necessary to name